pop up. It's not going to pop up because I already did it. Yeah, I think so, yeah. All right. Since everyone here knows how to program, I'll go through this super quickly, all right? So this is actually some material that I did for 256 last semester. There is actually what we dedicate one class in 256, the blockchain class, to talk about Ethereum stuff, and then we write a contract together. And by writing a contract together, I mean you copy what I do. Okay, so all right, this is very straightforward, right? So that's just the concept of variables, right? There's really nothing to talk about since everyone knows. I'm just going to skip ahead to how things work in Solidity, right? So to declare a variable, that's how you do it in Solidity. So it's similar to C++ and whatnot. It's type variable name equals value, right? I'm not going to break this down. Okay, I might talk about this. So a uint stands for unsigned integer. 256 is the number of bits it occupies. So the max value will be 2 to the 256 minus 1. There's uint, the smallest uint is uint 8. Biggest one is 256. I doubt anyone will need anything larger than 256. The other stuff, it's not very necessary. So some common Solidity types, right? So we have an address type. An address type basically represents, I'm just reading off the slide at this point, but it represents an Ethereum public address. Bytes 32 though, it's a 32-byte word, so you can use it to store letters, strings and whatnot. But it's limited to 32 bytes, so you're limited to 32 letters. And the reason why the largest is 32 is how many of you here are familiar with hashing? The concept of hashing? Yes. Yes. Do you guys want to kind of talk about what hashing is?
I guess it's like a way to make something like more secure. You have like a hash function. It's like to encrypt something. You pass into a hash function. The hash function gives back like a long type of like numbers or letters.
Yes.
Pretty much, and you have like the hash chains, pretty much like blockchain.
Yes. Yes. So so not so much encryption, because encryption implies it could be decrypted, which isn't what a hash function does. A hash function, it's more like it generates a fingerprint. So so any type of data that you feed into the hash function, it doesn't matter how big the data is or how small the data is, it will always, in this case, we're using SHA-256, that's what Ethereum uses. It will always return a 256-byte string or bit string. With that, just like a pop-up that keeps popping up. Yeah, it's probably this thing. It's a camera. So where am I? Yeah. So SHA-256, 256 bits, 32 bytes. 32 bytes. That's not a coincidence. This is very good at. This is most commonly used to store hashes. Now, the reason I said it's not encryption is because, again, it doesn't matter what the input is. The output is always 32 bytes, and there is a loss of information that's happening. So let's say you feed it a file that's 1 gigabyte. It's still going to give you a 32-byte hash, and you can't go in reverse. So it's better to think of a hash as a fingerprint, right? I mean, each person corresponds to each person has their own unique fingerprint, but just with the fingerprint, I can't reconstruct a person out of it. I think that's a good way to think about it. So that's just hashing, because even if you know programming, sometimes we don't really use it in conventional programming. But in Solidity, it's very important because storage on the blockchain is very expensive, and we usually don't store the data themselves on the blockchain. We store the hash instead. We store their fingerprint, so that when we're fetching data, we have a way of referencing the data or checking if it's the data that we actually stored. Sort of basically comparing fingerprints. There's also a Boolean type in Solidity, but it really is uint 8. It's in uint 8 underneath, although it is a little bit a waste of space, because a Boolean you only need one bit, just 0 or 1. But I'm guessing because uint, the smallest uint goes to 8, and they didn't want to redo it, so bool is actually a uint 8 underneath. A uint 256 There's also like UN 128, 127. So all the way from 8 to 256, you can do all kinds of UINTs. It represents a 260-bit unsigned integer. There's also int without the u. It would just cut the range. It won't cut the range in half, but it would just, half of it will go to the negative side and the other half the positive. But when we're programming smart contracts, I've been doing it for more than a year now. I've never ever encountered a scenario where I needed negative numbers, to be honest. So it's always uint. And also a fun fact, you might think that storing a smaller uint will be cheaper, but it actually isn't. Because to store a smaller uint, it has something to do with the way that storage is handled in Ethereum. So that even if you store a smaller uint, it has to do some accommodation because it's designed to work around this specific size. So if you use something smaller, it's actually going to cost more computing power, I think, a little bit more. So just use 256 all the time. At last, a mapping. So a mapping is a one-to-one relationship that maps a key. You can think of it as a key value pair, but the difference is a mapping. So it's kind of like a dictionary, or just a dictionary. So a dictionary in other languages. So just key value pair. But the problem is, unlike dictionaries in say Java or Swift for iOS stuff, in these languages you're able to iterate over the keys. So you don't necessarily have to know what the key is to find out what the values are. You can just iterate over the keys. But in Solidity, it does not keep track of the keys. So if you don't know what your key is, you cannot know what your value is. That's just that. A bit interesting. I did another sort of mapping kind of graph here. So let's say we're mapping a UN256 to a string. Now a string fundamentally is basically a dynamically sized byte. So the reason why it's more expensive than byte 32, the reason why we use byte 32 instead of a string is because when you have a dynamically allocated stuff, underneath it's actually very basic. It's a struct with I don't know how they keep track of it, but they need like something to keep track of the length. So it's just more storage space that's being taken up. So that's why we tend to avoid using dynamically allocated types in Solidity because they're more expensive. But in this case, we're mapping an unsigned integer to a string. So you can see there, I have like it's mapping at index 0. There's my name Jack, index 1. Chaz, index 2, Claire, index 5534, some other string, whatever, right? So we have all this. In other languages, you're able to just get the keys and then iterate over them. But in Solidity, you cannot. There's no way to get these. So you don't know if you don't know 5534 is a key, then you won't ever know this exists. At least not easily, right? So and this is like how you set it kind of. It's more or less like the other languages. Let me know, stop me anytime if you have any questions. But I think in a bit when we go through the Alchemy tutorial, I think it's easier to understand when you see all of these in action. I just wanted to give you some context. And we can even do more complicated mappings. We can have nested mappings. We can have a mapping that maps a uint to another mapping that maps a string to a Boolean. So now essentially we're creating something that's a little bit more complicated. We can have the first layer to be 200, we'll have the first layer of keys, first level of keys to be a uint. And uint can point to something else, and that something else can point to something else. So you can nest mappings like this in Solidity. So that gives you a lot more flexibility. And sometimes we use mappings instead of a struct. Sometimes we mix them. I believe in older versions you couldn't use structs as the value, but in newer versions you can. But by older I mean like from 3 years ago, so that's not really relevant. And I'm not going to explain what a function is. It's basically a reusable collection of related but smaller actions. I'm just trying to explain like what it is to like people who don't know programming. This is specific to Solidity, something called a modifier. So modifier is it's basically a function that gets run. It's a piece of code that you kind of decide to reuse very frequently. And instead of copy and pasting, either write it into its own function, but in Solidity, if you write into its own function, and if you let's say I want to enforce that only the owner of this contract can call a function. There's something called message.sender. So message would be the message is a global object in a transaction. So that's basically the transaction itself. So in message, there is an attribute called sender. There's also an attribute called data. There's also, I'm not sure if there's sender, there's data. I forgot what else. But message.sender basically means who called the contract. Now I'm comparing it to the owner that I stored that's already in the smart contract. So if they are equal, then it's fine. So I'm requiring, so this require is a Solidity keyword. It's basically whatever, so the first argument in require has to be true, otherwise it will revert the entire transaction. So here, if these are not equal, so if the caller isn't the owner, then I will revert this transaction, basically roll it back. So in Solidity, all the transactions are atomic, basically meaning it's either it's all or nothing. There's no halfway, there's no dirty state, because if something fails, then it rolls back all the way to the beginning. So it will. So if this is not satisfied, if this is not fulfilled, then it will revert with this error message. And this is how Modifier works. So imagine having to copy and paste this line every time. And this is like more straightforward, but if you have like something more complicated to check the logic, to do some like pre-flight checks for the functions, then you have to copy and paste them a bunch of times. With a modifier, you can just add this to the function signature and it'll do it. And you might have noticed this. So this underscore, it basically represents whatever code that goes after it. This is basically saying, okay, this is the end of the modifier, and basically add the function code, add whatever other code that's actually in the function. So this is basically saying that this is the start of the code of the actual function, and it basically denotes the end of the modifier. Yeah, that's modifiers. I'm already running a little bit too much, but this is basically how you would, and obviously it's a fake function, but this is the function signature. So first function to denote that it is a function. Start car, this is the name of the function. Also, you can add more arguments here. Only owner, that's the modifier name. So this modifier will be run before anything else gets run. Public is the visibility. In Solidity, there's private, there's internal, there's public, there's external. So private means that only this contract itself can call this function. Internal means only this contract and all of its children can call it. Kind of like protected in C# or Java. And then public means that everyone can call it. External means that only people, only entities outside of this function can call it. So you actually, if the function walk to car is external, I can't call it in the smart contract. Like if something is external, only the caller has to be external, because it does not generate a function information for itself, more or less. Like for the so basically the point is you can't call it in within the context of you can't call it from the same smart contract. And then returns is it denotes that the function has to return something. And then bool success is basically the return type and the return name. The name is optional. All right, more keywords before we go. We're almost done. So at the very top of any smart contract, you're going to see Pragma Solidity 0.8.0 or something. So that basically defines the compiler version. It tells the compiler which version to use. Because different versions of Solidity compiler actually, like some older ones, some newer ones. So the major increment is like 0.1. So between 0.7 and 0.8, there are usually bigger breaking changes. So some code that compiles in 0.5 will not compile in 0.8 and vice versa, because it's such a new language that they're still like kind of redoing the rules and improving upon it. So that just specifies the Solidity compiler version. View. A view is a type of function modifier. Not like the modifier as in the one that we write, but it basically defines that. So basically a view function means that the function is, it doesn't modify the state. So it's a read-only function, that's what it means. And calling a view function does not cost you any gas because it's read only. There's no write operation, so it doesn't cost any gas. A pure function means that, so a view function is able to read from the current state but not write to it. A pure function does not even read from the state. And so basically a pure function has nothing to do with any storage or anything. It's just a standalone function. It's like if I have a function that returns 1 + 1, that would be a pure function because it does not depend on anything else. And a pure function is usually used, let's say, for like hashing and whatnot, just to because there are subtle differences between hashing out between different hashing algorithms. And if you as a good habit, you should always explicitly define your source of truth. So let's say you're using hashing heavily in your smart contract. You're using it as some key. You're hashing some string, turning the hash into some key. So if you're doing that, then it's a good idea to have a pure function just to hash the string inside your smart contract so that you know it never changes. And abstract, basically, it's the same as other languages. An abstract function means that it's defined some functions, but it doesn't have all the implementations. That's mainly used for like interfaces. And we don't have to worry about these. An event. So an event in Solidity, I promise this is like the last one. An event in Solidity is basically, you can think of it as, I don't know, what's a good analogy? There's no equivalent to an event in other programming languages. So an event basically, it announces some data to the outside world of what's happening inside the smart contract. But the interesting thing is you cannot read your own events. So you do not have access to the events that you emitted in the smart contract. It is only visible to the outside world. But sometimes we use event for cheap storage. But then we get into like some other more complicated stuff that we'll talk about later. And we don't have to worry about interface. Oh yeah, I think that's it. So that's like my kind of like the primer thing. So take it away. Let me see if I can. Yes, so everyone can share. I think I just noticed I was muted, but I don't know if this is okay. No, but they have it. Yeah, they have a mic. Yeah, that's good. Okay. All right, cool. Take it away.
Is that my cue?
Yes, it is your cue.
Nice. Well, I mean, that was phenomenal. Thank you so much, Jack. We're recording, right? So gotta make sure I'm PG here. But no, I guess, Jack, do you want to kind of do introductions or how do you want to start this?
You can do it.
Cool, no problem. Yeah. So hey guys, my name is Nitish. I actually so I'm here kind of starring as a guest. I'm an engineer at Alchemy right now, currently working on the go-to-market team, but also doing some engineering work. We actually have one of our USC students named Enzo, who wasn't able to make it tonight, who actually interned at Alchemy this past summer. So Jack, I guess I can't really see anybody in the room because all I see is a bunch of blank screens. So I'm just gonna have to go off of like sounds, but how many of you know what Alchemy is or have heard of it?
I do.
Okay. Is it possible I can like see the people, or is that not a?
The camera is broken, unfortunately.
Okay, unfortunately. Okay, so I guess yeah. So some people have heard of Alchemy. I guess, Jack, would it be helpful if I kind of walk through what Alchemy was and kind of like how it worked?
Yes, I will. You know what? I will use my laptop camera just for you. How about that?
It means a lot, man. Thank you.
I have the virtual background. Whoops.
There we go. There we go.
Uh-oh.
In the meantime, I have a little slide that I can actually use just for some visuals. Might be helpful.
All right, there we go.
Cool.
Some high quality Apple product.
Dude, I need to get a new computer anyways. Mine is pretty slow, but hopefully should be good for the sake of this tutorial. Cool. So long story short, I'll kind of explain. Great to see you guys all in the room. I will go ahead and kind of walk through what Alchemy is. So basically the main purpose of today, 1 second, try to screen share here. Okay, can you guys see my screen?
Yeah, perfect.
Cool. So my main purpose today is going to be helping you guys walk through like exactly how to build a smart contract. So all the concepts that Jack was talking about, we're actually going to go ahead and implement them in real time. So I see a lot of you guys have your computers out, so feel free to follow along, but I'll give you guys a quick intro on what Alchemy really is. So to kind of give you an intro, Alchemy really is what's known as a blockchain infrastructure platform. We are basically, to put it shortly, a developer platform that basically allows you to build decentralized applications in the blockchain. Very similar to, if you guys know what AWS is and how it's been able to do server virtualization and abstract away the sort of pain and suffering of having to manage your own server. In order to read and write to the blockchain, as Jack had mentioned earlier, you have to use what's called a node. A node is sort of just one key component in an entire network of nodes that establishes consensus on the state of the blockchain, this immutable database and ledger. And so in order to read and write to that chain, you need to use a node. A node is essentially a piece of hardware. It can be a computer that's running Geth or any sort of software that's used to mine and or send transactions. And the issue that can arise when you're wanting to build decentralized applications is that when you're running your own node to manage your decentralized application, when you want to scale your application, scale the amount of requests coming in, you're going to need to buy more nodes. So similar to how if you think about a traditional website or a web application, you're going to need to buy more servers as you scale to manage more load, to manage more requests. You're going to need to establish a load balancer and queue requests across the stack. You're going to do something pretty similar in the context of decentralized applications. But the issue is that to buy nodes and to manage more hardware, to have to pay for more server access and a download Geth on all of your machines can be a really, it's a huge hassle and a really burdensome process. So Alchemy has really built a very robust node infrastructure on the back end that it sells as a service to folks like me and you to easily build on the blockchain without any hassle, and manages the back end entirely so that developers like you and I can focus solely on sort of the user experience, the product experience. And a lot of, we power tons of the top crypto companies you've probably heard of: OpenSea, DYDX, ZeroX, Yearn Finance, PwC, Aave, a lot of the crypto projects out there. And we're only getting started, and we're powering, I think, over 70% of the Ethereum ecosystem. So basically the leading blockchain developer platform. Kind of going to walk through here. These are just some of our investors. This is actually a sales deck that we use, so I'm not going to bore you with all the slides, but just some of
what you want to add real quick.
Yep.
The Geth that Nitish was talking about, it's a Go implementation of the Ethereum client. So it's what you need to run a node and synchronize the blockchain. So that's just what Geth is.
Exactly. Think of it as like basically it runs the software that allows you to go ahead and read and write to the blockchain. And it also contains, the EVM, which is the Ethereum virtual machine, all these different lingo we can go through later. But yeah, so essentially we power, I think at this point we powered over $30 billion in transactions. And most of the top, like you've heard NBA Top Shot, CryptoKitties, all these different projects, they're all powered by us. Some of our investors, obviously our team. I'm going to skip the slides that we use to sell our customers and just give you the good stuff. So we talked about this. So for example, this is us in the news, all the NFT platforms, we power the back end, and this really allows platforms to focus solely on user experience. So kind of, I do want to sort of skip through a lot of these slides and just kind of focus on why it's important for folks like you and me. So if you notice any sort of revolution in technology, there were essentially three. We saw the computer, we saw the internet, and now we're seeing the blockchain. And today, if we sort of take a sort of time travel back in time, back to when 1999 was around and the internet was just starting, or even back before that when the computer was just starting, historically, when new technologies have emerged into the ecosystem and into the world, trying to build on top of these technologies, you're trying to build applications using these technologies has always been like using a pick and a shovel, right? And in the beginning, when we were making websites, like these very, sparse, very sort of hacky read-only websites that almost were just virtual newspapers, we essentially were using picks and shovels to build stone huts. Very primitive tools. We had to manage things on our own, and it was very sort of primitive and wasn't allowing us to sort of reach our full potential in terms of what we could build. And every single time a revolution came along, somebody came along and decided to actually build the tooling to make the build experience and the developer experience far easier and more robust, so that you can go from building stone huts to mansions, right? And so being the bulldozer of the blockchain, being the tools that enable developers like you, me, and all these countries across the world to actually enable an entirely new revolution of value transfer across the world, that's what Alchemy's mission is, to empower developers to be able to build some of the greatest products that exist of all time. And I think we're going to be able to see that in the next 10 to 15 years, 20 years, 30 years. And this is kind of a very helpful actually diagram that kind of outlines what Alchemy does and the potential that it has. So like we talked about, there were three revolutions in technology: the computer, the internet, and now blockchain. The computer allowed us to, instruct a machine on some instructions and allowed us to sort of give a machine information and store information. The internet allowed us to transmit information seamlessly and transmit instructions from computer to computer. What's unique about the blockchain in this case is that the blockchain allows machines to transfer value. And that's why the blockchain, and in general, you see a lot of these revolutionary technologies have been able to really spark a ton of interest. And every single time we've seen layers emerge on top of these technologies to enable developers to build. So in the computer, to manage the low-level system calls and the kernels that exist in the CPU, trying to help, like developers who are trying to build on top of the computer. The Microsoft operating system came along, as well as the Apple Mac OS came along to build a middle layer on top of the computer that enabled developers to actually build software, the software you see on your computers, like whether it's Figma, Microsoft Excel, Google Chrome. These layers allow a very easy abstraction, a high-level abstraction for developers to build on top of the computer. When we saw the internet come along with the HTTP protocol, TCP/IP, FTP, all these different, sort of protocols of how we transfer information across the internet, that scaffolding needs to have a layer that was built on top of it to enable developers to build all the applications we see today, like Zoom, Palantir, Netflix, Uber, Postmates, all these different applications. And AWS was that middle layer, that server virtualization that enabled developers to really easily build on top of the blockchain. And now we've essentially sparked, if you look at all the top companies today, they're all infrastructure companies. Google has its own infrastructure division, Microsoft, Apple, Amazon Web Services. Amazon Web Services, as we know, Amazon, it has a shopping business and its web services business. The web services business takes up 2/3 of the bottom line and has $1 trillion market cap. So you can just see the potential that infrastructure companies have in the world of technology. And now we're seeing the advent of the blockchain, this new scaffolding, this new method of transferring value. And Alchemy is this middle layer, this infrastructure that enables, whether it's NFTs, decentralized finance, exchanges, identity auth mechanisms, to be able to build on top of this chain and utilize the value of the blockchain to its fullest potential. And sort of this is just some of our, our product set. I kind of won't bore you with all the details, but we have in addition to our Supernode API, which allows developers to build on top of the blockchain, we have a suite of developer tools to really enable lots of different sort of use cases, like monitoring your app, enabling notifications, lots of other things. Like we said, there's a lot of challenges to running nodes. I won't go through them, but the main ones are there's downtime whenever you're running your own nodes. Scalability, we talked about, can be an issue. Data correctness is also a huge issue, and I'll spend a bit of time on this. The short end of it is that when you want to use nodes to read and write from the blockchain, because as we know, every single node stores its own copy of the blockchain, trying to obtain information from a given node might be, basically making calls to the blockchain is asynchronous. And what I mean by that is when you're querying different nodes for a certain transaction, or you're trying to look to get some data from the blockchain, you might be requesting from different nodes that have different perspectives on the blockchain. And because those nodes have different sort of versions of the blockchain downloaded and they're asynchronous due to the consensus mechanism, it might cause for a very poor user experience if you're looking to query a certain set of data and you're getting back a different response every time. And what we've done is we built a really robust consistency layer in the back end to enable real-time data correctness and scalability, so that you'll never run into this sort of asynchronous nature that comes with trying to read and write to the blockchain. And this is sort of just a very high-level diagram of our stack. I won't spend too much time on this. A lot of these that we use for our sales deck, I won't go through all of them. But the short end of it is that we support tons of chains. So not just Ethereum, but we support Flow, Optimism, Arbitrum, Crypto.org, and we're going to be expanding to tons of others. And really, we are sort of the best-in-class solution for being able to build on blockchain. So I think that covers it. Before I head into the developer component and actually get into the cool smart contract stuff, does anybody have any questions? I know I just kind of zoomed through it, so I'm really happy to answer any questions. Yeah, go ahead. Just shoot. I can't like physically call on you, but I can see you. Yes.
Is the fact that Alchemy runs or supports 70% of the biggest like applications on Ethereum threaten the decentralized values of protocol?
That's a really great question. I think you pretty much asked the same question that our CEO Nikhil gets at every single press conference. And the answer to that is that what our job is not to build user experiences or to manage data on behalf of people or applications, right? If you're OpenSea and you want to, let's say, mint an NFT on OpenSea, Alchemy doesn't own your user data, neither would it want to, and neither would it want to own any of the assets that are stored on the blockchain. We're solely the sort of middleman, the infrastructure that enables developers to easily build. In terms of a centralized infrastructure, this definitely is sort of a component that's been queried about in terms of, still the infrastructure, even though the data is not centralized and none of these sort of operations are centralized, the infrastructure is definitely still centralized. And the sort of logic here was that building decentralized infrastructure, as an example, made for a very, very poor UX in the V1. So our goal was, hey, we really want to enable for customers and users to be able to experience the best user experiences and for developers to have the best experience developing. So we wanted to create a platform where they could have the best reliability and the most sort of data correctness and scalability. And we realized that for a V1, that Web 2 would be a really robust way to enable that. However, we definitely have been thinking about ways we can try to decentralize our node infrastructure more and think about scaling that more effectively. But for now, what we've found is that using Web 2 infrastructure at the moment to build this infrastructure on the back end has allowed us to enable a better customer experience and also allow developers to way easily build better without running into a lot of the sort of asynchronous data reliability and data correctness issues that you're experiencing when you normally have to run your own node, if that makes sense. But to be very clear, we don't really, we don't own, Alchemy doesn't own any of your data. So no one can hack Alchemy and try to steal any of your private keys and or your assets. We're solely just the infrastructure that allows you to communicate with the blockchain. Does that help answer your question?
Yeah, definitely. It just kind of makes me wonder, like hypothetically, if Alchemy had like some Bond villain CEO, like what could they possibly do with the fact that you guys are running 70% of those nodes, or 70%?
We don't run 70% of nodes, but we power 70% of top Ethereum applications. So to kind of just correct is not necessarily that we're running the nodes, because we can't quite literally like own all 70% of the nodes. That would be impossible. But we do for the top crypto companies. So the statistic, to be clear here, is we power 70% of the top Ethereum applications, and that includes like a lot of our top customers. But to be clear, like more likely if you were to run your own node and or leverage it, like use someone else's node, you would most likely not be using Alchemy unless you chose to use Alchemy, if that answers your question.
Yeah, that fully answered my question. Thank you.
Yeah, but I mean, definitely, no, to kind of just follow up on that, it's centralized node infrastructure is definitely the best customer experience and the best solution at the moment. And because Web3 is evolving so fast, we definitely are, and lots of infrastructure companies are looking to explore the idea of building decentralized node infrastructure. Our logic was that we wanted to build the best product possible and the most high fidelity product possible to enable the best experience. And then we could go from being centralized to actually building a decentralized way of thinking about things. But definitely we have to watch as this sort of space evolves on that front. Anybody else have any other questions about Alchemy as a whole or any technical stuff? None? Cool. Sounds good. Sounds good. Cool. If we I guess we have no more questions.
Let me take the camera away from you for like 1
Yeah.
minute. I'll open it back up. But you can keep going. There's
Sure.
yeah.
It's nice. I will go ahead and actually in the meantime I'll pull up some of my. So yeah, I guess if you guys can see me, I would encourage you guys all to get out your computers. So we're just gonna go ahead and build a smart contract today. That's gonna be sort of the topic of this. I'm really excited to get into this and kind of show you how you can easily use Alchemy to get a smart contract up and running in a few minutes. Whereas like, if you're doing this by yourself, you'd have to like really go and buy your own computer and do all this other crap that you don't want to do. But let me go ahead and pull this up. Cool. Can you guys see my screen? Oh, I need some yeses because I can't tell.
Yeah.
Yes. Okay. Sweet. Okay. Cool. So again, so do we have any questions regarding like any smart contract or Alchemy stuff before I hop in? Cool. Sounds good. So cool. So today, what we're going to be doing is we're going to be, and then feel free to follow longer. If like at any point none of this makes sense or something doesn't make sense, just interrupt me and stop me and ask questions. Because if none of you are understanding or one of you aren't understanding, then I'm not doing a great job explaining. So I really want to make sure you guys are getting the best experience out of this as possible. But today we're going to be building our first smart contract for probably many of you. Maybe for some of you it's your second or third. But we're going to be calling this our Hello World smart contract because, as you know, traditionally in the programming paradigm, whenever you build your first program of some sort of language and or using some sort of framework, usually you'll build some sort of program that logs Hello World. So that was kind of the motivation behind this. We wanted to create a very simple smart contract that stored a message that said Hello World, so you guys can actually see what it's like to deploy a smart contract to the blockchain. We're going to be using what's called a test net for this tutorial. And what that means is it's basically a fake version of Ethereum and the blockchain. And before I kind of dive into that, how many of you like understand how we use Ethereum to run smart contracts in the blockchain? Like, is there anybody here who doesn't really understand like what gas fees are and how like ETH works? Feel free to just shout because like I don't feel embarrassed because this stuff's like very new.
Yeah, here I'm not a coder or anything, business major. So everything is like pretty new for me. So yeah, if you can touch on like those stuff, I'll appreciate it.
Absolutely. I love that, man. Like, yeah, thanks for being so brave and asking and 100%. Like, even, you know, we're always learning. I'm always learning every time I go through this again and again. I'm always learning. But the short end is that, as we know, I'm sure you understand like how Bitcoin works as a peer-to-peer payment technology.
Yeah.
Cool.
So this club kind of explained a little bit about, so I know a little bit.
Sweet. All right, nice. So you can think of Ethereum as, you know, it technically ETH, the cryptocurrency associated with Ethereum, is a cryptocurrency, but Ethereum has a very different use case than Bitcoin. Bitcoin is mainly a peer-to-peer money sort of transfer mechanism, versus Ethereum is really, you can think of it as a decentralized ledger and a database to be able to build on top of and build these super cool decentralized applications like OpenSea. And what we are doing when we run a smart contract is, in order to run any kind of code, like the code you see that technically underlies all the jobs and processes that are powering my computer and allowing me to talk to you over Zoom, all of that power is being run by electricity, right? Every single program that needs to be run on a computer requires computational work. And we have to pay for that computational work in the form of electricity. That's why we have electricity bills. So when you think about running a smart contract, it requires computational work to actually execute that code. And so you can think of sort of, you've probably heard the term gas before. You have to sort of pay what's called gas, or a fee, in order to actually execute your smart contract to compensate the blockchain for the computational work that it will perform to run your program. So you'll pay in ETH to actually run your program because your program requires computational work. Does that make sense what I'm saying? So what we can do is we can actually use a combination of different kind of signature mechanisms, like discrete log signature mechanisms and Schnorr or Exta, to be able to actually sign these transactions that we need to propagate to the blockchain in order for us to actually power our code. Does that make sense? I'm looking at my fellow business major. Does that make sense to you?
I think that's a little bit technical. I'm trying to understand.
Think of it as that you just sign transactions, and those transactions have a certain amount of money associated with them. And that money, that transaction, you can sign and say, hey, I want to dedicate this transaction to running a certain piece of code. Does that make sense?
Yeah.
Okay, cool. So that's what we're going to be doing today, is we're going to actually be writing the code for the smart contract. And then we're going to go ahead and take that piece of code, put it on this decentralized ledger base known as the blockchain, and then use our sort of fake currency to actually run the code and pay for it. And we'll use sort of a wallet. A lot of, today we're going to be using Metamask to sign that transaction and authenticate it. So hopefully that kind of gives you some more color around what we're doing today. And like I said, feel free to interrupt me with any questions. So we're going to be walking through deploying the smart contract using a combination of different tools. We talked about a virtual wallet, Metamask. So as you can see, this is kind of this fox up here. Really solid tool just for custodying your crypto assets. So you can store things like Bitcoin, Ethereum, Solana, Matic, all these different tokens if you'd like. Today we're just storing some test Ethereum, which basically means that we don't actually have to like buy Ethereum with real money. We can just actually use like some fake Ethereum and on a fake net to kind of show the effects of what blockchain look like. We're obviously going to be using Solidity, which Jack touched on. I don't have to explain that. Simple, developer language for being able to build Ethereum. We're going to be using a development environment called Hardhat. And or you could use an environment called Truffle. Truffle is also a bit more legacy. Hardhat's like sort of the newer kid on the block. But Hardhat we found has some better sort of enhanced methods to be able to do what we're doing today, and also has some pretty interesting plugins that we can enable to sort of instantiate some microservices that we're going to use. And then obviously the sort of king of the hill here, Alchemy. This is sort of the underlying infrastructure, the underlying sort of entity that allows us to do everything we're doing today. And so, if none of these terms make sense to you, do not worry. We're going to walk through them step by step. And actually, quick promo here. If you guys actually have any questions in your smart contract development, we have a completely free Discord that you can just join by clicking on that link. And I can also go ahead and drop this link in the chat. I don't know how many of you are on the Zoom, but just, might help. You can go ahead and just join that Discord and ask questions away, and for free, we'll answer your questions. Me and a few of my other colleagues. So let's get started. First thing we're going to do is we're going to actually connect to the Ethereum network. And to do that connection, as we mentioned, we need that node, that infrastructure provider. And today we're going to be using Alchemy. So Alchemy's built this really simple API to allow us to communicate to the blockchain. So what I'm going to go ahead and do is, if you go to www.alchemy.com, you can actually go ahead and think about logging in. So go ahead and log in here. Normally, if you don't have an Alchemy account, you're going to need to sign up pretty easily. I won't go through the sign up flow. I actually already have my own personal account here. So I'm going to go ahead and just log in. So what you're seeing right now is what's called our sort of core dashboard. This is where you can keep track of not only all your developer tools, like some of the developer tools we have up here at the top, which I can be happy to go into later, but also we can have a running track of what apps we're actually building. I was kind of playing around with an app earlier today, so I call this project 1, but this is a really simple dashboard that summarizes not only the apps you're using, but all the activity you're taking up, like how long your response times are, how much you're getting rate limited, the amount of requests you're making, et cetera, et cetera. And you also, if you want to type some feedback in, you can as well. We'd love to hear from you. But first thing we're going to do is actually we're going to go ahead and create the app. So we're going to go ahead and click on this button here, create app. And in order to, and following along with the tutorial here, and I'll actually go ahead and switch to this so you guys can actually read it as well. We're going to go ahead and click create app, and we're going to make this app on what's called the Ropsten test network. This is basically just a test net that's built on top of Ethereum. And we're going to name our app Hello World for the sake of this tutorial. So feel free to follow along here. And we're going to do this in what's called a staging environment, which for those of you who are engineers understand this, but those of you who may not be, staging is basically sort of a sandbox environment where you can go ahead and test stuff, kind of work around stuff, work through bugs before you actually release it into real production. So we can go ahead and call this Hello World. Just call it our first smart contract. And then we will put this in staging. And this will be on the Ethereum chain. So this is the actual core chain that's going to be on using the same consensus mechanism that Ethereum uses, unlike some of these other layer 1s and layer 2s. If you don't know what that word means, don't worry about it. It's kind of a technical term. And then we've got our network here, right? So we're going to go ahead and choose the Ropsten network just for the sake of our tutorial. And we're going to go ahead and create this app. Now, obviously, well, actually, no, it may not be so obvious, but if you're using an API, sort of an API being an application programming interface, allows two things to connect, allows two applications normally to connect. To use an API, you need to sort of authenticate yourself through a password or sort of pseudo password known as an API key. So this app not only sort of tracks everything we're doing, right now we haven't done anything, but also gives us an actual, not only an HTTP API key, which is sort of an API key compatible with the traditional HTTP protocol, the client server model, but also a two-sided WebSocket protocol for things like event listening. And if you want to go ahead and integrate a front end to your smart contract, WebSockets are a really robust tool. Before I go any further, are there any questions to understanding like how we create an Alchemy account or any errors or anything that I should cover before I move on? Cool. I'll assume no. Feel free again to interrupt me. So first thing we're going to do now is we're going to actually go ahead and create an Ethereum account. And actually go ahead and create a custody account where we can store Ethereum. We're not actually going to be storing real Ethereum. We're going to be, as we mentioned, storing this test ETH. So what we're going to do is go ahead and download Metamask. So I actually already have Metamask downloaded in my browser. I'm not going to go through that whole sign-up process. But if you quite literally just go ahead and Google Metamask, like Chrome extension, you can just go ahead and Google it, and then you can go find it, actually download it. Pretty simple. You're going to have to go through some steps, like some private phrases, secret phrases, and all that stuff. But once you're done that, you can assume that you can just sort of append it to your little Chrome, and you'll be able to actually access Metamask straight from your Chrome extension. As you can see, I'm using a new one, so I only have like a little bit of ETH, but this is actually like test. Actually, I don't have any ETH, so I have 0 ETH, but I do have some test ETH, which is really good because we're going to be able to use that as rocket fuel to power our program. So that's why we have this wallet, not only to custody our test ETH, but also to sign our transactions, because it sort of has a library in the back end that uses a discrete log signature algorithm, which is a very technical term, to actually go ahead and sign our transactions and propagate them to the blockchain. But the long story short is we can use this wallet to go ahead and send transactions and also receive them. So the next thing you're going to need to do before you kind of move on is actually going to need to add test ETH from what's called a faucet. This is really just simply like a website that you can go ahead and put your public address. Jack, did you get a chance to cover public key and private key cryptography at all when you were not? Okay. But just think of a public address as literally just like we talked about, like SHA-256 and some of these hashing algorithms. You can just think of it as a sort of an address that, hey, if let's say I want to get ETH sent to, and Jack wants to send me 5 ETH, I can give him my public address, and he can go ahead and direct that 5 ETH to go to this public address, and it'll actually come to my account. So what you'll do is you'll enter in your address, and this faucet will give you test ETH. To be quite candid, faucet experiences have been historically terrible user experiences, and usually won't even give you any test ETH unless you try really hard. So actually, Alchemy is looking to try to build a better version of a faucet. But for now, let's hope that it works. If it doesn't, feel free to ping me after the tutorial, and I'm happy to send you guys test ETH because I have tons of it. So no problem if you guys don't have it right now. But for those of you who may or may not have test ETH, you can just follow along now, and then you can definitely, I'll go ahead and send a video that actually covers everything after this tutorial.
Another way to think about the public and private keys is that you can think of the private key as your email and password combo, whereas your public key is just your email. So your public key is what you give to other people to give you information, or when you're trying to send something to other people, that's what they see. But you never give out your password and your email.
Absolutely. That's a really good explanation. And actually, there's a really helpful diagram that I can send afterwards, but I think it's gonna load. So like, for example, this is kind of a good diagram on what does everyone seen this, by the way? Okay, cool.
Yeah.
Everyone sees this. Great. So like the very short end of it, as Jack was beautifully described, I couldn't have done it better. Basically, there's sort of an algorithm that's used out there called Exta, which allows you to generate both a public and a private key pair. Think of this account number as the public key, and your private key, as you mentioned, you do not want to share your private key. It's like the key to your mailbox. Don't share it. And then what you can do is you can actually create signatures using this private key, and you can kind of guess why you wouldn't want to share a private key. Because if you share your private key, that means other people can send and receive actually send transactions on your behalf. So spend ETH. And imagine it's like giving your credit card to somebody who you don't know. They can go ahead and spend all your money and basically like make you broke. And you don't want that to happen to you. So store your private keys and never, I repeat, never share your private keys with anybody. So you can use your private key to create a signature that can authenticate transactions. You can send that with a transaction, and then you'll have this sort of algorithm on the back end that verifies stuff using your what's called public key. And I'm more than happy to send this diagram to anybody who wants it. Feel free to ping me after, and I'm more than happy to do that. That's like your little crash course lesson on public private keys. So you'll basically, when you request your ETH, you'll eventually get your test ETH in your MetaMask wallet. And once you have it, you can actually move on. And this is a kind of a cool chance to start kind of getting, cool, sort of a, hip and savvy with the blockchain by actually using this very no-code tool called the Alchemy Composer tool. So it doesn't matter what major, where you come from, what kind of technical background you have, very simple low-code tool to be able to actually check your balance. So what we're going to do right now is I have a certain like 5 ETH, test ETH in my wallet. Let's actually go and test that by making a request to the blockchain. So what I'm going to go ahead and do is I'm going to go ahead and use this method called Ethget Balance. This is just a traditional Web3 library call that you can use to basically get the balance of a certain public address, on the blockchain. So what you can do here is we can actually specify what kind of chain we're looking to request from, what's the kind of test net or main net we want from, so Ropsten, what's the method, Ethget Balance. You can actually see what the Json Rpc request looks like. For those of you who don't know what Json Rpc is, it's just another version of a kind of protocol that's used to communicate between different machines across the internet. And it's a bit more robust and scalable than the traditional HTTP protocol that you are usually using on the internet. And we can use it to actually communicate with the blockchain as well. And so then what I can do is I can actually go ahead to my MetaMask wallet up here, and I can go ahead and paste this public signature or this public key in my actual address box. And then what I can do is I can get the latest block number, which stores my balance, and I can send the request. And what you'll see come back is you'll actually see this response. So this is your request. You'll see this response that comes back, which actually shows you a hexadecimal value of how much your ETH is actually worth, which is really cool because actually what this value is denominated in is called Wei. So one ETH is equal to 10 to the 18th Wei. So if we actually go ahead and we can go like hex to decimal converter, we can actually input this hexadecimal value into the converter. And what you'll notice is that if you convert it, it'll actually be this sort of large decimal number. And you can see if you basically track back a bunch of zeros, namely 18 zeros, it's 4.99999 ETH. So therefore we can actually say, oh, look, we actually have 4.99, aka 5 ETH. Does that make sense to everybody? Yes. Okay. Everyone's on board. Great. I love it. Like I said, feel free to stop with any questions at all. All right, cool. So now we like understand what a wallet is. Like, let's just see how far we've come, guys, because this is pretty cool. Like, we understand what an API key is, like how the infrastructure works. We now understand what a wallet is. So keep in mind, for like comparatively to most people in the world, like more than 99% about blockchain and crypto than most people. So like, give yourselves a pat on the back. It's like pretty good. Like we're actually like learning a shit ton about blockchain. So now what we're going to do is actually go ahead and create the project and actually get into writing this code. So first thing we're going to do is we're going to go to our terminal here. We actually go ahead and create our project. So I'm going to go into my terminal right here, and I'm going to go ahead and cd into my desktop. And for those of you who understand, like, this is like very simple, like just navigate around the terminal using Linux. Don't worry about like any of the weird syntax. You can usually copy and paste whatever on the website. So first thing we're going to do is we're actually going to make our directory. So we're going to use the make dir command. There we go. And we're going to call this.
Can you make your terminal font bigger?
Oh, 100%.
Yeah.
You guys see?
Still pretty tiny, to be honest.
That's good.
How about that? Is that good enough?
There we go. Yeah.
Okay, sweet. Yeah, like I said, feel free to interrupt me at any time if you have any questions or need anything from me. But we're going to go ahead and make our directory. called Hello World within our desktop. You can do it wherever you want, really. I just want to be able to visualize it. And then we can go ahead and we can actually cd into our directory here. So now we're actually in our Hello World directory. And as you can see, there's a little directory, a little folder that's been instantiated here within our operating system. And so now what we're going to go ahead and do is we're going to install this package called npm. I won't really go into what npm is. It's like an executable environment. It involves a lot of like really interesting microservices, but we're just going to use it to like run some code that we're going to write today. So we're going to go ahead and initialize our npm init, our package. And just because it asks you like a crap ton of questions I don't want to answer, I'm going to use a yes flag. This just skips all the questions that it asked me. So I'm going to go ahead and run all these modules. It's going to go ahead and do a lot of installation. So actually run it. So it's going to install the package, or it's going to, initialize the package, excuse me. And then what we're going to go ahead and do is we'll skip all this question stuff. We're going to actually go ahead and download, using this package, we're going to download what's called Hardhat. And just as a reiteration, Hardhat we can think of as a development environment to compile, deploy, test, and debug Ethereum code. It doesn't actually, it contains a compiler, it contains all these really interesting things we're going to need to actually compile and run our code. So it's in our best interest to use some sort of tool like this. Hardhat, in my opinion, is one of the better ones, but also Truffle. A lot of people may disagree with me and say Truffle is way better. I'm not gonna get into politics on that, but definitely use whichever you feel. We actually have a component in this tutorial, the written one, if you'd like to go ahead and use Hardhat. I'm sorry, if you'd like to go ahead and use Truffle. But today we're gonna be using Hardhat. So I'm gonna go ahead and run this. And this is just gonna do some like fun downloading stuff. Yeah, this might you guys can run on your own too. This might take a while. In the meantime, while it's running, I want to take questions in the meantime. Are there any questions that anyone has on anything we've done so far, or any package, anything I can answer?
How'd you get there?
How'd I get to where?
Like to where you're actually writing code? Because
Mhm.
like I'm still at the part where I'm trying to set up the Robson faucet thing.
Okay.
And it keeps saying that like I don't have a valid Ethereum address. Am I doing the right thing? Like when I go
Is it saying that on the faucet page, or is it saying that in your actual like Alchemy account,
the
or where's
faucet page.
Ooh.
Yeah, that's not
Okay, hopefully it. So
Like,
this is why I say faucet experience can be really shitty, because hopefully it's just not bugging you out on you. But I don't know. Did you try just copying it again and inserting it?
It was a wrong copy. Fixed.
Okay, cool. We're good. Everything's solid. Right. Like I said, literally interrupt me with anything. By the way, if you see anything like that says found like some security vulnerabilities, you can go ahead and try to run npm audit fix. I'm not going to do that. You really trust me, like you actually don't need to worry about any errors here. I would let you know if there's actually really big errors to worry about. I've done this a million times. This is not going to cause any problems. So now we're going to go ahead and actually create our Hardhat project. So we've gone ahead and installed the package, but now we actually need to go and create an instantiation of a project. So let's go ahead inside our Hello World folder. Let's get rid of all this, gibble gobble, and we'll actually run this. And so now it's just going to ask us like, hey, what kind of project do you want to create? What we want to do is navigate to this option here that says create an emptyhardhat.config.js. Is everyone seeing this, or anyone who's for anyone who's following along, like, is this showing up for you? Or are you guys noticing this?
Yeah, we can see it.
Okay, everyone's good. Is there anyone who cannot, or anyone needs questions or help?
I think we're good.
Cool, sweet, let's do it. Right, so we're just going to navigate. Say something.
She's on Windows, so I don't know if she can do it. She's on Windows.
Did you
Can you
hear
say that a
that?
yeah, no, I didn't hear it. Can you say that a little louder?
What do we do if we're on Windows?
Oh, that's a great question. I'm actually not super familiar with the Linux commands on Windows. I've never used in my life. I will say is like, do you know how to like make a direct, I mean, are these commands just not being compatible with your OS?
So what we've done is basically just created a new folder, navigated to it,
Mhm.
and then I'll try to fix it for you.
Sure, yeah, for sure. Yeah, I mean, exactly what Jack said. We literally just created a new folder. We're going to navigate inside that folder, and then we're going to run a certain kind of package. And then we're going to instantiate, we're going to run another sort of development environment called Hardhat, and then instantiate a Hardhat project. I really, really wish I could help you on Windows, but I've never used Windows in my life to write code. So I hope that sort of problem gets fixed. But for now, we're going to go ahead and create this emptyhardhat.config.js. Now I've actually created the file. So if you actually ls into our folder here, we see that we've created this emptyhardhat config file. We have our node modules from our npm, and we have a bunch of these extra sort of auxiliary files that we're going to need to actually go ahead and develop. So I'm going to go ahead in here, we'll scroll down a little bit. And what we're going to do now is we're going to add some folders. So one folder we're going to add within our project directory to maintain our actual contract, like the actual code we write, the Solidity code, which Jack was beautifully describing in the beginning. And then we're going to actually have a directory for our scripts, basically just an execution program that actually deploys and runs our script. Deploys and runs our contract. So we're going to go ahead and create 2 folders within this hello world. We're going to create, sorry. Someone say something?
Some of them don't have npm, so.
Okay. Oh, I see. So
not everyone is a developer.
I mean, did you guys install? If you don't have npm, you can use npm install.
I'm working on it. Don't worry.
Okay, cool, no problem. npm install should just solve your problems there. But we're gonna go ahead and create a folder scripts, and we're gonna go ahead and create a folder contracts. And yeah, and just for sake of spelling, it's with an S on the end, just so that you guys aren't. You can name whatever you want, really, if you want. But anyways, we created those 2 folders, and now we can actually go ahead and finally, after all this explanation, go ahead and write the contract. Sorry, does someone have any question? Or no? Okay, cool. Hey, we can actually go ahead and write the code now. So what I'm going to do is I'm going to actually go ahead and navigate to my favorite text editor. I like to use VS Code, but if you like to use Atom or any of these other, sorry.
I'm also trying to find
We're good.
We're good? Okay, cool. If you want to use Atom or Sublime, you can use any of those different text editors, or even if you want to use Vim. I'm not a big fan of Vim, but whatever you want to use, you can use. I'm going to use VS Code today. So now we can go ahead and exit out of that terminal, and I'll go ahead and open up my VS Code. And as you can see, right, like especially if you have it on your desktop, which I do. So if we have the folder on our desktop, you can see the folder here. So we're gonna go ahead and go to in VS Code. If you're in VS Code, you can go ahead and File, Open. Right, and then you can actually go ahead and navigate to Desktop and go to Hello World, which is right here. And you'll notice that you'll actually see Hello World with all the packages and all the modules here, and our hi-hat config file and our empty contracts and scripts folders. So hopefully this is working, and hopefully, does anyone need time to get up and running, or can I move on? Good. Okay. Sweet. So now what we're going to do is we're going to actually create a contract within our contracts folder. Pretty self-explanatory. We're going to actually, for the first time, this may be the first time for some of you, but we're going to go ahead and use .sol extension, which is our first Solidity program. It's going to be really cool. If you'll notice when I write my Solidity, it'll actually have like a cool bunch of highlighting and syntax stuff. You don't need to actually have that to actually run the code. So if your code doesn't have all like the fancy colors and stuff, doesn't matter. It's literally just an extension you can install in VS Code, which is like takes 2 seconds to install. Just look up like Solidity extension. But regardless, we have a compiler, right? Because we installed Hardhat. So we'll be able to actually compile our code with or without this fancy extension. So we're gonna go ahead and create a file called Hello World. You can use camel case if you'd like, and do .sol. So we've instantiated this, and you'll notice the nifty Ethereum logo to the left of it, which sort of explains that we have Solidity code. And we're gonna go ahead and we're gonna copy and paste. And I promise I'll explain how this works, but just to avoid having to type it and possibly make a mistake and have tons of compiler errors, I'm gonna go ahead and copy and paste this code. And I'm gonna go ahead through line by line and explain exactly how this Solidity code works. So this is what our smart contract is. And basically I call this like a hello world message smart contract. So I'm gonna go in depth onto like what's going on. So, and again, stop me if anyone has any questions. So the first line, I think Jack had already explained this, just defines a compiler version we're using. Today, we're gonna be using, a Solidity compiler. This is like a compiler directive that you can use like C++, all these different languages. And then we're gonna be doing any compiler version above 0.7.3. So we're going to mainly be, I think like now the latest version, Jack, correct me if I'm wrong, but it might be like 0.8.0. I know that was 0.9 actually. So yeah, never mind.
0.8.9.
Yeah, dude. So exactly. You see how like fast the space is evolving. Like compilers are moving like crazy. The language is moving like crazy. Software is moving like crazy. So it's important to just keep up and yeah, learn as much as you can, which is what we're doing today. Jack, did you stop the camera or?
Yes, I'm
no problem. Take your time.
Computer for a bit.
Take your time. So then what we need to do is actually instantiate our contract. So this constructor here is called, this is a contract keyword, which basically instantiates our contract, defines a contract. We're calling it hello world, pretty self-explanatory. And we can think of a contract similar to like, in C++ or C as like a struct or a class or an object. It's just a collection of functions and data. And then once you deploy a contract, one of the unique things about blockchain, which, Jack may or may not have explained earlier, is that on the blockchain, when you deploy this piece of code, this object, this sort of collection of functions and data, it's what's called immutable. And when we say immutable, what that means is it means that you cannot modify the actual data that's stored on the chain. So in this case, we're quite literally storing the exact lines of code on the blockchain. So what that means is like, while you can sort of update like what variables are pointing to, and if you kind of have a low like understanding of low level languages like C, you understand like what pointers and casting is, like you can change like casting, you can change like pointers, you can change what variables like point to. But what you can't do is you can't change any of the logic of your contract or any of the sort of variables or data or any of the bytes that actually make up your contract. So once you actually instantiate your contract on the blockchain, it's completely fixed. The memory is completely fixed and all the logic is completely fixed. Now, technically, there are some really interesting, like sort of cutting edge innovations out there, like upgradable smart contracts that OpenZeppelin's been able to develop that enable sort of the iteration and sort of agile software development on the blockchain. Just for the sake of this tutorial, we're not going to focus on that, or we're just going to kind of focus on a traditional vanilla understanding of what a smart contract is. So that's what a smart contract is. And this here is what's known as an event. Now, I think Jack explained this a little earlier, but I kind of like to think of it as event as like logging in a certain language, right? Like whenever you're sort of, let's say, use a console log or maybe use a print function, it's a little different than that in that, like, you know, when you use some of those logging functions, you might be using it for the sake of debugging. Like maybe you insert a console log function somewhere in your code to see if your code actually got to some sort of part of your control flow. But normally, like, you know, we use an event to try to communicate and propagate information when an event happens on the blockchain. And we can call this sort of event using the emit keyword down here, which we'll get into in a second, to actually communicate information externally. And what's really beautiful about that is whenever, you know, think of the smart contract as your backend. It's all the backend logic. It's all the business logic that runs to enable and to define how your program is going to work. But sometimes you'll need, like, you know, most time, anytime you build a smart contract application or DApp, you're going to need a front end for users to interact with. And when users do things like click buttons or mint NFTs or send transactions or do anything that's associated with a decentralized application, you're going to update the state of the blockchain. Like, remember we said, we can still update the state, we can still update the variables and what they point to, we just can't update the logic of the contract. So whenever something gets updated or a certain, you know, executable gets run or a piece of code gets run, an event will actually, you can set up events to actually trigger and notify the front end to say, hey, we just executed this code, we executed this contract, let's go ahead and let you know that we've done it, and we can now go ahead and update the front end as needed. So you can use like an event listener, right? As you know, if you guys have worked with JavaScript, you understand how event listeners or on-clicks work, event handlers. You can use event listeners to actually register when events propagate information to accordingly update the state in your front end. I hope that makes sense what an event does, and I hope that covered it well. Does anyone have any questions up so far? Okay, cool. Let's move on. Like I said, please interrupt me or let me know if you have any questions. Next thing we're going to do is, like, this is one of the most, probably the most simple smart contract you'll probably ever write, is we're basically just going to store a string variable of a message. And kind of how Jack mentioned, we can use a public keyword to just sort of tell the program that, hey, listen, like, other people can access this variable and also use this variable as a actual function keyword, right? So we can actually use the message function if we'd like. We can get into how we're going to do that later, maybe in a separate tutorial if you guys want to hit me up. But for now, just think of this as a buffer or a variable for us to store information in, namely characters in a string. So we can use any message we want. Namely, our message is going to be hello world. We're going to create a constructor. For those of you guys who understand programming, you know what a constructor is. But for those of you who may not, super quickly, a constructor is like a function that gets called when you actually instantiate your smart contract. So when you want to call it, let's say you have this sort of, like we mentioned, this contract hello world is like an object that exists somewhere on the blockchain. And when you want to call and actually create that object somewhere in your code, you need to call a constructor, which basically instantiates or that creates the object in your code. And you can actually pass in parameters to set certain values upon creation. So what we're doing today is we're actually setting a variable or a parameter in here called init message or an initial message that can update the variable with a custom message that we decide to input. So we're going to make message equal to whatever string we want to input. And we'll actually see that since Solidity is a type language, it's type safe, and we can actually see that, okay, you know, we actually have to input a string. We can't input a series of, you know, numbers or some sort of other kind of piece of data. And that's what a constructor is. And lastly, what we're going to do is we're going to create this really cool update function. This quite simply is just, you know, it updates a message variable. So you can kind of see the logic. What it does is it takes in a message and it will, first of all, save the old message from earlier. It will update the current message variable with the new message that we passed in. And then we talked about events earlier. This is where it gets really cool. We'll use this events function to actually send to the external Ethersphere, hey guys, what we've done is first of all, here's the old message. So it's going to basically emit an old message and a new message, right? We pass an old and new. We're going to emit the old message that we used to have. Let's say it might have been hello world. We're going to, you know, also emit the new message that we have. Maybe it's like, I don't know, like I need to take a nap or I love blockchain or something like that. I bet you the first one probably applies to a lot of you know, tired college students. But the point is that that you know, we're going to be doing that, and we're going to actually be able to propagate that information to the Ethersphere and to sort of the collective people who are viewing this blockchain, as well as any front end that might be integrated with this that's listening to what's happening on the blockchain, and specifically with the smart contract. So that's what the update function does. I hope this helps a ton. Does anyone have any questions before we move on? Because understanding this is very fundamental to understanding how smart contracts work. Yes, you have a question?
What does the memory keyword mean?
Sorry?
The memory keyword. Memory.
The memory keyword. Okay, so this memory keyword, I mean, actually, Jack, do you want to explain that? You might be a bit more, well, I can explain if you'd like, but you know, if you want to.
Yeah, so a memory keyword, you know, I think it's a whole another can of worms. Let's do it later. I'll explain it later.
Yeah, it's basically like you can think of memory.
But just know that there are three types of whatever kind of keyword this is called. There's memory, there's storage, and there's call data. I'll explain that later.
Yep. It gets a little bit, that's why I was asking Jack, because I understand what it is, but it's just, it gets very nitty gritty. And I think that personally, Jack is way better explaining this stuff than I am, because he's way more experienced than me. So, yeah, so 100%. But like, please feel free to follow up with me. And like, also, if you want to follow up with Jack, I'm more than happy to help you out. I mean, you know, I'm also a college student like you guys. So, you know, totally know the hustle here and the feeling. So we've created the smart contract, and we're now going to go ahead and actually do some cool stuff with it. Namely, we're going to deploy to the actual blockchain and see, like, no matter what, anyone can view your code on the blockchain, which is like pretty sick when you come and think about it. So what we're going to go ahead and do is we're going to actually go ahead and connect when we talked about that MetaMask wallet earlier that can store the test ETH. Now is where it comes time to actually use that sort of test ETH to go ahead and deploy the contract. So we created the MetaMask wallet, we've created the Alchemy account, we've written our smart contracts. So like, again, pat yourselves on the back. You've done a lot here. Like, this is some pretty cool stuff. And like I said, you're light years ahead of anyone else who claims to understand blockchain. Like, this is some really in-depth stuff. So like, really cool that you guys are here and you guys are, you know, in the weeds doing this stuff. So what we're going to do ahead now is we're going to actually go ahead and install the Dot Env package in our project directory. You can think of a so what we're going to need to do is we're going to need to store some very sensitive data about our wallet and about our sort of that API key, that password that allows us to use the Alchemy platform and the Alchemy API. We need to store a lot of that sensitive data in a very protected file. And this Dot Env package is a package that allows us to store information in a very protected ecosystem, namely a file that basically like has properties that allow it to be very secure comparatively to other files. Especially when it comes to any sort of like if someone's trying to hack you or access your database, env files are just known to be a very secure place to store your variables. So what we're gonna go ahead and do is I'll open up my VS Code terminal here. And again, please interrupt me with any questions you might have. And within our root directory, so now within like our contracts, just be very careful here. Now within our contracts or our scripts directory, but within our entire root directory, so our hello world directory, make sure it says hello world at the beginning. What we're gonna go ahead and do is we can go ahead and copy this command npm install .env, and we're going to save it. So we're going to go ahead and install this package. And we're going to wait for that to download. Again, please feel free to use this time to ask me any questions. But we're going to go ahead and download that. And we're going to see is obviously like if you notice some of these security vulnerabilities, like I said, don't worry about it. It's probably not going to affect you. If it does, let me know. But I guarantee you it's probably not going to matter that much. So now we're here and we can say, okay, let's actually go ahead and store some of the variables in our .env file. So what we're going to need to do is we're going to need to get our, first of all, our MetaMask wallet private key, which by the way, I will walk you through how to do. I will obviously unshare my screen when it comes to getting my private key, because like the mantra I said, and like Jack said, do not share your private key with anybody and under any circumstances. And just a pro tip, if any application or any sort of service you're ever using in decentralized web or in the blockchain space asks you for your private key or your secret phrase to your private key, you should automatically know that it's a scam. Like I repeat, no legitimate blockchain application will ever ask you for your private key. That should be yours and yours only. So just please like understand that. I really don't want you guys like losing all your ether or just, you know, ruining your application because you decide to give someone your private key when they try to trick you into it. And then also similarly, like do not give anyone your Alchemy API key. Right now we're creating a demo app, but like let's say you actually want to create like a fully, you know, scalable application. Maybe you want to actually go make it a business. Like you don't want to have to like accidentally lose your API key and then someone starts like screwing with your application, DDoSing it, sending it tons of requests. You don't want that. So you want to make sure you keep these things safe. So we're going to go ahead and we're going to create a .env file. And just one last, you know, sort of nitpicky clarification, create it in the root directory, not in any one of these sort of child directories. You may notice it's getting created in the child directory. Don't do that. Click out of this and make sure you aren't selecting any directory. And we create in the root directory. This is very important. And don't call it like file.env or like solidity.env or like any name.env. It's literally just like the name .env. This is like really important. I get like tons of questions in our Discord about it. Oh, why isn't my env file working? It's just because you didn't name it properly. And if you named it properly, you should see this little gear next to it. That's how you know you did it properly. We can go ahead and paste that code. And you want to keep these variables, by the way, because we're going to be using these later. So we just want to make sure we're keeping the API URL and we can define it. So I'll go ahead and walk through how we're going to actually get our HTTP API key and also how we get our private key. But before I do that, does anybody have any questions so far? Nope. Cool. Like I said, stop me with any questions. Cool. So what we're going to do is what you'll see, I actually clicked into it, but you're going to sort of see your dashboard and you've created your Hello World application like we did in the beginning. It's in staging on the Rpc network. We're going to go ahead and click on the Hello World app. And what we're going to do is we're going to navigate to this button at the top right here that says View Key. So we have this one-sided client-server HTTP key, and we have the two-sided WebSocket listening key. We're going to go ahead and use the HTTP key because we're just deploying. We're not doing any sort of front-end stuff here. We don't need the WebSocket. We don't need that two-sided connection. So now we can go ahead and, sort of, I showed you for like a very brief second. I honestly don't think this is like a demo app, so I'm not really worried. But if you guys are building like a fully stacked, like actual like app that needs to be a business, please don't share your API key. We're gonna go ahead and paste that. I'll leave it there quickly. And then we're gonna go ahead and get our private key. I'm actually not gonna show you my private key, but I'm gonna explain how it works and how do you get it. So first, what you're gonna do is you're gonna go to your Metamask wallet, right? You're gonna make sure you're on the proper test net. So the Ropsten test network in this case. You'll ideally, and hopefully if you don't have a shitty faucet experience, have some test ETH that's sitting in your actual wallet. You're gonna navigate to these three dots here, and it's gonna say account details. So you're gonna click on account details. And then you're going to look at this sort of, button that says export private key. And then you're going to need to type your MetaMask password. So you'll type it in, and I'm obviously not going to click enter yet. I'm going to unshare my screen. But what you would do is you will click this confirm button to actually get your private key. So I'm going to go ahead and unshare my screen, right? Just so I can get my private key. I encourage you guys in the meantime to get your private keys as well. And go ahead and confirm. And then it'll say like a message that says, this is your private key, click to copy. You're going to actually go ahead and copy that key. And then I'm going to go ahead right now and put it in my env file. And to be clear, you want to make sure both your HTTP API key, so your API key from Alchemy, your Alchemy API key, but also your private key are enclosed within those quotations. It just makes it easier. You don't want to have to worry about like whether there's any debugging problems. Just keep it in those quotations. So now you should have all your sensitive information in that .env file. So now what you're going to do is go ahead and click in once you're done that to your Hardhat config file, and we can go ahead and move on with the tutorial. So. And we're almost at the, and now we can go ahead and, not only do we have the compiler, we have all the code, we can actually go ahead and make the request using a really nifty Web3 library called Ethers.js. There's lots of different libraries. There's like, there's Web3.js, there's Ethers.js, there's Alchemy Web3 library, which actually is much more, it's much better for if you're trying to actually scale your application and you need to use like much better enhanced API methods. But for the sake of this tutorial and just for simplicity, we're going to use the Ethers.js library. But the Alchemy library actually has the same methods that the Ethers one has, just a bit more enhanced for sort of more scalable use cases. But right now, we're going to basically, so like I said, it's a library that allows you to interact with the blockchain and wraps around these, I think we talked about this earlier, this Json Rpc method stack. And what a Json Rpc is, it's just a protocol that allows you to communicate information across a network. And that network, in this case, we're communicating across is to the blockchain. And so Json Rpc is a lot more robust and scalable than the traditional HTTP protocol in some certain use cases. In some certain use cases, you might want to use HTTP, but that's a separate discussion. You can take a networking class if you'd like. And the reason we're using Hardhat yet again is because we can actually integrate plugins really easily. So we can use like the Ethers plugin. We can use tons of different plugins really easily with other development environments. It's a bit different. For the sake of this tutorial, we're going to use Hardhat. So I'm going to go ahead and do now we're in our Hardhat config. So first thing we're going to do is we're going to actually install our Ethers.js library. So we're going to go ahead to our root directory. So just again, remember, and I'm going to try to make this bigger if I can. Can you guys see my terminal here?
Beautiful.
Okay, sweet. I'm going to zoom out just a little bit. Okay, beautiful. Remember, if you guys don't see anything or any problem, just let me know. We're going to paste that command in our terminal, and I'll try to expand this a little bit so we can get more of that, right? So then we're going to go ahead and run this in our root directory, in our hello world directory. And then we're going to let it run. And in the meantime, anybody have any questions about any of the tools that we're using right now? Cool, sweet. So we just downloaded our Hardhat config file. And now we can actually go ahead and actually update our Hardhat config file. We download our Etherjs library, and now we're gonna actually go ahead and update our Hardhat config file, this sort of repository that stores all of our plugins, to let it know, hey, we have Etherjs downloaded and we want to install some stuff on it. So what we're gonna first do is there's a few things that are going on here. So we have this required Dot Env config. We talked about the required keyword earlier, but basically what this does is it pulls in your environment variables. So those Dot Env variables, that's sensitive data that you don't want to show. It allows you to pull it in sort of a zero knowledge way. Actually, I shouldn't use that word zero knowledge, it's a bit loaded word. It allows you to pull in your data and your env variables without actually needing to know what they are in the outside. You can just sort of trust that they're there. And then you can go ahead and bring in the Hardhat Ethers library. It's basically just defining, hey, within Hardhat, this is the Ethers library, and it allows us to sort of instantiate Ethers within the Hardhat environment. And then what we can do is we can sort of deconstruct the what we call this sort of process env keyword. It's just basically a way for us to deconstruct sort of what deconstruct the env file into our respective variables, which are, if you've done it right, you had and you guys can check your env files. You should have your API URL first, and then your private key second. It will deconstruct this properly. If you do it in the opposite direction, it's going to make your API URL the private key, and then your private key the API URL. You want to make sure you're doing the right way. And then after that, we can basically, what we noticed already is that the version of Solidity within the module is already defined. So that's already beautiful. And now we can go ahead and actually copy in our default network, right, which is Ropsten, right? So you want to make sure we specify that in our module. And then also we want to make sure we specify our networks, right? So just to be clear, we have Hardhat here, right? We have Ropsten. And then within Ropsten, we also want to define, hey, what's our actual API key, which is here, right? And then we actually want to define our accounts, right? This is like where our private key actually lives. So that's why we're using the private key variable. So that if someone's looking at your code right now and you're showing them your code, or you need debug or something, no one actually knows what your private key is. It's just stored in a variable, so no one can actually see what's going on behind the scenes. I'm going to go ahead and just make this a little cleaner. Should have auto formatted, but it didn't. And in the meantime, does anyone have any questions, or Jack, do you want to say anything, or are we good here?
I have nothing to say.
Oh, sounds good. Nice, great. So yeah, let's keep moving. I mean, I'm talking a lot, but hopefully the stuff I'm spewing out of my mouth is valuable to you guys. If it's not, let me know. But anyways, so right now let's just see how far we've come, right? We've defined our plugins. We've gone ahead and stored our sensitive information, our env file. We've written our contract. We've established all the necessary tools and microservices that we need to deploy the smart contract, right? And just to keep in mind, this is way, way, way easier than us having to run our own node. If we had to run our own node, it would be a really difficult and just sort of, gut-wrenching process. And right now we're able to do this in the span of a workshop because we have a tool like Alchemy. Without a tool like Alchemy, we wouldn't be able to do this so easily. And this is why, sort of Alchemy is, in my opinion, a very revolutionary tool, and it's really helpful for you guys when you want to build. And we'll give you a surprise at the end in terms of some of the perks Alchemy can offer, especially college students. But next, what we're going to do is we're actually going to compile our contract. So remember, we had talked about the pragma keyword and all that other cool stuff. We have our version of Solidity, and we have our compiler version, right, which is right here. And now we can actually go ahead and use the Hardhat compiler to actually compile our code. As we mentioned, we want to do this within our root directory and within our actual hello world directory, not within any one of these individual subdirectories. So let's go ahead and compile. And ideally, if you've done everything right, and I hope I have done everything right, you should get a notification that says compilation finished successfully. Now, a lot of you may notice this yellow error that says SPDX license identifier. I won't get into what that means, but just know that it's not that big of a deal. If you're seeing the error, don't worry about it. You're going to be fine. Computer's not going to break.
It means if you allow other people to copy your code.
Exactly.
So it's a licensing kind of thing. You don't have to worry about it.
Yep, don't worry about it. So you're not breaking anything. I promise. If there are any errors that don't look like these, just let me know. But this tutorial hopefully will not break your computer. But then what we can do is we can actually write. So we talked about making a scripts folder to actually run the code, right, and to execute the code. Now we're going to go ahead and actually high level define how we're going to execute the code in our scripts folder. So we're going to create a file within our scripts folder called deploy.js, right? So we're doing this in JavaScript, and hopefully, and I think that just to be clear, if you want to develop in Solidity, coming from a JavaScript background is pretty helpful, because a lot of the syntax looks pretty similar. And also Solidity uses some asynchronous directives. And so if you understand how asynchronous programming works in JavaScript and promises and stuff, you'll be able to kind of get your head around how Solidity works. But also it's a good idea to have, as Jack had mentioned, some understanding of lower level languages like C and C++, which is why we all learn that in school, because like understanding how like compilers work and like memory and all these other things is pretty important when it comes to developing in Solidity. So, and then also having a good understanding of cryptography is also a really good idea too. Definitely some classes that Jack teaches I'm assuming are very phenomenal for that. I'm gonna go ahead and copy this code in here, and I'll explain line by line what this does. So, to kind of explain for those who know JavaScript, you can kind of just tune me out right now. But for those of you who may not understand this, we'll walk through it. This is sort of so what we're doing right now is we're defining what's called an asynchronous function. Really quick definition of what an asynchronous function is. It's just a function that like does something. So let's say you want to do something, like a function is just a way to do something. Instead of actually, normally when you want to like execute lines of code, you'll go through and you'll execute each function one by one. And when you're doing a function, right, what you'll usually do in normal synchronous program is you'll run the function, you'll wait till the function returns its result or finishes, then you'll go on to the next line of code. The problem is at sometimes, like you'll sometimes wonder like, oh, how come I can go ahead and click on like a load like button on this web page, but then if I'd like to, I can exit immediately while it's still loading. Or like let's say it's running slow, I can X out of things, right? Like how come you can do stuff like that? It's because of what's called asynchronous programming. It allows programs to say, hey, I'm gonna go, and this is very common for when you're doing things like connecting to networks or you're trying to like, like fetch data from a database. That takes a really long time. So instead of halting the code and saying, hey, let's not allow the user to do anything else, or let's not update any more state or do anything else that needs to be done, what instead the program is saying, let's define this function and say, let's just go ahead and send the request or call the function. And then while the function is running in the background, what we're going to do is still run all the lines of code that go below it. And then whenever that sort of function in the background gets done running and actually gets as a result from a network or from a database, we'll actually go ahead and return the result wherever it is in the control flow of the program. For my one business guy in the back, does that make sense to you? Or asynchronous program is really hard, so if it doesn't make sense, totally understand. Does that make sense?
Sorry.
Sorry, no, I didn't mean to call on you, man. That's all my bad, man. I didn't mean to like scare you, dude. Long story short, man, just think of asynchronous program. It's like when you want to answer a text, right? Like that's called asynchronous communication. Instead of calling somebody in real time and having to like respond to them in real time, you can receive a text and then think about it in the background later and then respond to somebody later, right? That's like what asynchronous is like. So you know,
I have another analogy that's very good.
Go ahead.
I used it with when I was teaching CS 201. So I'm guessing everyone takes a shower, have taken a shower at some point in their lives. When you take a shower, you usually go ahead and turn on the tap first because water is cold. Synchronous programming means that after you turn on the tap, you just wait there, do nothing. Wait until the water is hot, and then you go ahead and take a shower. Asynchronous means you turn on the tap, you can work on something else, and then come back to it.
That's beautiful, beautiful. It literally couldn't say it better. Like you literally like do something, and you can go ahead and do other stuff in the background while that thing is still loading or running. And then when that thing gets done, you can return back to it. And usually programs will have like usually when you're running the tap, in this case, like Jack mentioned, you'll maybe like run your hand under the water, you'll kind of feel it out, and then you'll be like, oh, it's hot enough. Okay, I'll go in the shower. The equivalent of that in programming is what's called like a listener, which like basically listens for when something gets done. But the short end of it is, right, we're calling this function main, this sort of running tap, and we're calling it, we're saying, hey, in here, so ignore this, like we're just defining the function here, the main function. The actual control flow where the function actually starts is here. And since the function is an asynchronous one, we're just saying, hey, let's call the main function, right? And all this stuff is going to run in the background. And then there's this keyword then that says, okay, when the function is done, when it actually gets back the data that we need to get, we're going to basically, it's called an arrow function. But what we're going to do is we're going to take this data and we're going to first of all exit the program. So this keyword exit just exits the program with a proper opcode. It's called a 0 code, which just means like we've done a successful run. And then what we're going to do is that in any case there's an error. So this is kind of the directive they use when it's called promises in JavaScript. But like basically when you want to run a promise, or what it means is a promise to get something back. So you're going to go ahead and get that data back. You'll run this execution. You'll run sort of exiting the program. And then you'll go in here and say, hey, but in the event that there might be something that is out of the ordinary, so we'll catch an error, what we'll do is we'll pass in this error and we'll say whatever that error is, which is stored in this error variable. Well, first of all, console error, which is basically a fancy word of saying print. We'll print the error, and then we'll actually return the program with a termination code of 1, which means like, yo, something messed up. That's not good. So it just tells a computer like, yo, like there's an error here. But what we would like to see is we'd like to see that code run that's in this main function, right? So we'll call it, we'll run this code in the background. And then when it gets done, we'll actually go ahead and exit with a satisfactory opcode that says, hey, everything's good. So basically that's like asynchronous programming 101. And now we're gonna go ahead and explain what this all does. So const hello world, just simple definition of variable. And we see this thing called await Etherjs contract factory. You're like, whoa, what is this? Don't worry, I'll explain. So basically, first what we're going to do is pass in the name of the smart contract. As we can see, we defined hello world in camel case, and we now are mimicking that here, and we're passing the string hello world. So we're going to actually go ahead and define that. And actually, if you go to the tutorial here, you can see it's pretty well defined. Actually, it might actually be better if I just read it because it's really well defined by Hardhat. Sorry, it's taking a bit. Okay, so basically what a contract factory is in that library Etherjs, a contract factory is an abstraction, right, used to deploy new smart contracts. So hello world here is a factory of instances of our hello world contract. When using the Hardhat Ethers plugin, all that instances are connected to the first signer. The short end of it is saying, hey, look, we have a collection of these different contracts, a factory of them, and we can use this object, this variable, to deploy the contract. And guess what we're going to do next? You guessed it. We're going to deploy the contract. So we're going to say, hey, let's actually go ahead and deploy it from that contract factory that's sitting up here on line 1. Or actually not line 1, but it's like line what? I don't know, like 2, right? So we're going to go ahead and start the deployment. And we talked about promises. I won't get into what that is, but the point is, remember we were talking about asynchronous programming? Here, this await word, all it's saying is, hey, let's call it a deploy method. Let's wait for it to be done. And while we're waiting, right, we can go ahead and return this sort of this string contract deployed to address, right? And then what's going to happen is it's going to wait because it's going to be like, oh, we don't even have this data yet. When are we going to get this data back? And then eventually what's going to happen is once we get this data returned to the hello world, and we're going to say, hey, like, look, first of all, it's going to deploy the contract. It's going to get it all done. It takes a lot of time. Then we're going to say, all right, now we're going to return the result, which is basically the address of the smart contract. We're going to return that to this variable. And then we're going to, it's not just the address, but it's going to be a lot of things, a lot of metadata. We'll return this object of data, this sort of like package of data to this variable. And then we'll access one of the fields like address. And we'll say, hey, let's print contract deployed to address. Does that make sense? Cool. I'm glad it does. So like I said, stop me with any questions, but this is just a contract factory. We deploy it, and then we'll print to our console, our terminal, saying, hey, we've deployed it. Here's the address. So let's actually go ahead and do that. So we now understand what this script does, and now we can actually go ahead and run this script. So let's just copy this command from the Hello World Smart Contract tutorial, and we're going to actually run it in our terminal. So we're going to do npx hardhat run scripts deploy.js. That's the file path, and then network rops it, right? Because that's our test net. Let's go ahead and run it. And if everything works properly, we should see the message printed to our terminal. Beautiful. Take a look at that. It says contract deployed to address 0x22. It's this hash address, right? Like it's sort of it's this hexadecimal address, and that defines a place where the contract actually lives on the blockchain. So, like, by the way, if you guys have done this, like, give yourselves a huge pat on the back. You have quite literally just deployed your first piece of data to a global blockchain. Like, anybody in the world, no matter where they live or where they're from or who they are, can look at that address and see your code on that address. So it's pretty cool. So let's actually go ahead and get into the ROPS and Etherscan and actually take a look at our code. And actually, I'm going to go ahead and quickly verify the contract as well, so we can actually see the source code living at that address. Right now, we won't be able to see the source code just because it's not verified. But what we can do is we can go to our contract, and we'll notice that, hey, it says, look, let's look at this. We just did this file 45 seconds ago, so we just deployed the contract. Here's the hash. It's just like a proof of work, or it's just sort of like a proof that's saying, hey, like, here's the transaction. And then what we're going to say is, hey, look, this is actually not a proof of work. Technically, that's the wrong term. It's just a proof that says, hey, like, we've done the transaction. And then we're going to say it comes from this address. And what does this address look like? Well, I know what it looks like because I own the wallet. But if you notice this address is your wallet address. See 0xEC64. We have 0xEC64. So it's coming from our wallet. What we've just done is we deployed, right, our contract. And in order to deploy it, we need to sign, right? We need to do some work. We need to write to the blockchain. This is a really fundamental concept here that I want to explain, is when you write to the blockchain and deploy code and actually mint or sort of, engrave your code on the chain that can never be changed, you actually have to expend computational work to do that. Now, obviously, this is a test net, so it's not real money, but what you're going to need to do is pay for that, right? And what we need to do is sign the payment to actually deploy that contract. So what our wallet here is doing is saying, hey, I'm going to go ahead and use my internal signature mechanisms like discrete log or Schnorr or any of that stuff to basically sign the transaction that's dedicated to actually deploying this contract on the blockchain. Does that make sense to everybody? Okay, I'm glad it makes sense. So you can see, like, I've done a lot of stuff with this wallet too. So you can see like a ton of stuff in the background. But right now we'll see that like it's a contract creation. And if we actually go to our contract, we can see the details like, look, this is a status, we are successful. And actually what's really cool is it's even, so this stuff looks like a bunch of like gobbledygook, but if you actually go to like our dashboard, it provides a really concise way to see what's going on. So if you go to what's called a mempool, how many know what a mempool is? Or do you guys understand what a mempool is? Okay, super simply, it's like when you send a transaction to the blockchain, it gets like thrown into this ether. It's like this random, like just sort of purgatory of like bunch of transactions sitting in the ether. And then these people, these nodes, these anonymous nodes on the blockchain will say, yo, my job is I'm going to basically take a bunch of these transactions that exist in this purgatory. I'm going to package them into a block, right? That's why it's called a blockchain. I'm going to package them into a block and I'm going to do a bunch of math stuff to basically verify that this block has valid transactions and that can also be attached to the chain properly. And when we say mined, what that means is just a sort of code word to say it's a colloquialism for saying the node has taken a bunch of transactions in the purgatory, has packaged them into a block, has run a bunch of math, and has basically verified that this block can be appended onto the global blockchain that exists. In this case, it's Ethereum. So Ethereum uses the proof of work consensus mechanism at the moment to do this stuff. And what you'll see is that it actually mines a transaction and there's a hash that describes it. And if you go into here, you can actually keep track of every single transaction that you ever make in this mempool, which is really, really robust because there's no other tool out there that does this. So it's really beneficial, especially if you're running scalable systems where you're going to need, let's say there's a transaction that fails or customer's unsatisfied, you can actually go ahead into your mempool watcher and look for every single transaction and debug accordingly. So it returns all the information, very simple UI, network, block number, the amount of gas you paid, right? We talked about paying for computational work, the nonce, which is just like, the number, is a sequential right number for an address. We can talk about it later. Address, all this other stuff, value, blah, blah, blah. Okay. So now what we can see is that on this sort of blockchain, all the same information lives here too. Now, what I'm going to quickly go ahead and do. So by the way, just want to say like, congratulations. What you've just done, if you've gone through this with me, and also if you go through this afterwards, is you just officially deployed your smart contract to the blockchain. Now, one thing I'm going to do actually is I'm going to actually sort of verify this real quick. So if you actually go to submitting your contract to the Etherscan, you can follow along with me. But like a lot of you were like, oh, this is really cool, but like I want to see my source code. Right now, if you go to the contract, it says this contract matches. Actually, so for some reason the source code is living here. I think it may be because I already had deployed by. Oh yeah, sorry, actually I already deployed a contract earlier. But I'm gonna still go ahead through the steps. But okay, let's take a look at this contract. You'd actually go ahead and see. So normally you'd have to verify your contract. A lot of you won't see this because you haven't verified it yet. But when you want to actually verify your contract, you'll actually see that every single line of code, even the like comments, are all written on the blockchain. So like if you go ahead and take my address, right? Like I'll go ahead and copy it right now if you guys want to look. You can go ahead and take my address and I'll put it in the chat. And if you put that into the search bar of the Rotston test network on Etherscan, you can actually see my smart contract with my public address, which is really, really cool. And you even have like the settings, the API, which is like a bunch of other cool stuff. And you can also see some of the events that occur when you actually do it. Right now, there's none because we haven't updated the message rights because we only emit an event when we update. But I'll quickly go ahead what it takes to actually verify your smart contract, just in case you guys want to see your source code too, and then I'll wrap up here. So first thing we're gonna need to do is actually go to Etherscan and make an account. So what we're gonna need to do is like, let's just say we go to Etherscan. You're gonna want to sign in here. Etherscan.com or .io. We're gonna sign in here. And then I have like my own login. Create your own, oops, sorry. There we go, I gotta click that. And then what you'll want to do is, in order to verify this, you'll go down to this little, by the way, so is everyone following along, or you guys have any questions? Or cool. Okay, cool. So we'll go to this API keys bar. And what we can do is we can add an API key. It's like pretty similar to like adding an app on the Alchemy dashboard. I've already added one. So we're gonna go ahead and when you instantiate, you'll like, make a description for it, you'll continue. And then you can take this API key token, you can copy it. And then what you can do is you can actually go back into your env file, right? And I'll just show you what it looks like on this screen, but I'm not gonna actually like go into my env file. But if you have your API, you ignore this public key. You don't need this like field. This is for like a separate tutorial. But you can actually put your Etherscan API key into your .env. So what that means is like if I go into my env file, I'm not going to show you my private key, but all you have to do is just make another line and then put the variable there. So I'm going to go ahead and do that right now. You can actually go ahead and do that real quick. Yeah, so go ahead and quickly insert that. finish this off, what we can do is now that we have, I'll get out of my env file just to avoid my private key. Okay, cool. So we're back. And I just basically put in this Etherscan API key into my env file. And then what you can do is you can install this sort of Etherscan plugin for your Hardhat. So quickly, we'll just, npm install that within your root directory, by the way. Make sure you do that in your root. And while that's going, what we'll do is we'll actually put some lines of code into our config file. So we're going to go ahead and require. We're going to require keyword the Etherscan plugin. Put that in there. Just installing in the meantime. And then we're going to need to add like a little bit of code to our config file just to define like what's going on in the Hardhat config. So we're going to go down here. We're going to actually, oops, that's a lot. Format this real quick. All right. And then, great. So now we have this struct in here, which is good. And then what we're going to do lastly is we're going to use this contract command, which is npx hardhat to verify command. It's on the Ropsten network. And we're going to replace, and I should actually modify the tutorials afterwards. We're going to replace this keyword here with our actual contract address. So one thing you want to do is, right, when you actually have your contract address, you want to make sure that you actually save that, right? So if we go back here, I'll go back real quick, Etherscan login. Actually, I'll do it all. Go back in my history real quick to find it. Right. So here's our contract, and then what we can do, right, is we can first of all we can paste this command here, and then we will go ahead and replace this contract address variable. This is the last step with our actual like contract address. We're gonna go ahead and take this contract address, right? We'll just copy it. So this is the contract creation you're seeing here. And what you guys are going to see is you're not going to see your, you're not going to be able to view your contract yet. You have verified it. We're going to go ahead and verify right now. So we'll paste that contract address here. And then what should happen is you'll click this, and I think it should work even though I already verified it. But if it doesn't, it'll probably work for you though. Okay, I'll say nothing to compile, I guess. But it will say successfully submitted code for contract verification. It's going to wait for the result. And like I said, remember, like this SPDX license, don't worry about it. Might take a minute, but okay. So yeah, if you take a look here, it says successfully verify contract, hello world on Etherscan. It will actually give you a link to where the contract lives. This is really cool. So now you can go ahead and click this, control click it in VS Code, and you can actually see, now I already had it, but now what you should be able to see is actually it shows your contract source code right here on the actual blockchain, which is like really cool. So now you can actually see like every single piece of source code. And remember, this kind of is in alignment with like what's going on and why the blockchain exists. It's an immutable public ledger of data. So anyone can see your source code, right? Now, there's a lot of innovations being done to maybe try to like mask this stuff, but for now you can see your source code. And also the source code is completely immutable. It's unchangeable. So no one can screw with the logic, right? But what's really cool is now you've officially deployed your first smart contract to the blockchain, and you can do tons, like imagine the kind of stuff you can do with this, right? Like there's so many different kinds of cool programs you can build. And Alchemy, by the way, on their documentation has like tons of different tutorials. Like a lot of you probably heard about like what an NFT is, or like these really cool pieces of digital artwork. You can create your own using our tutorials. You can make your own app that actually mints NFTs for other people. You can go ahead and make tons of cool full stack V apps and also integrate front ends, which we'll teach you how to do using this sort of documentation. So it's really helpful. And I know this has been a pretty interesting and in-depth tutorial, but I hope this helps, and I hope this like really got you guys interested in smart contract development and building the blockchain. And hopefully you sort of are able to utilize the full effects of all these tools, including Alchemy, to be able to make your development experience as good as possible. And I'll paste that link in the chat. But that's pretty much it. If you guys have any questions, let me know. But thank you for having me.
Thank you.
I also want to add that you can like read and write directly from Etherscan your contract once you verify it.
Yes.
As well, so that's cool.
That's fine.
Yeah.
Look at
How many of you guys like thought that was like dope? Like any like, yeah, okay, nice. You got some like interest. How many of you guys thought that was like terrible tutorial and I need to do better next time? Please be honest.
Easy. That was super
Yeah.
easy.
So I have a quick question about I mean, I don't have a question right now, but I would love to know more about Alchemy as a company. Simply, I'm senior, I'm looking, somewhere to work. So if there's any way I can contact you, that'll be great.
Yeah, of course.
That is coming up.
Of course, please feel free. I have my email, right? You can feel free to put in I put in the chat here. That's that's my Alchemy email. You can feel free to share. This is my Stanford email. You can use whichever one you want. But yeah, I mean, what in terms of like just if there's opportunities, yeah. I forgot I sent that. Really cool flyer that our designer made like last night. Scan that QR code and you can, so to be clear, this is where like the fun surprise comes. Okay, here goes. So a lot of you guys just learned how to build your own first smart contract. Maybe you guys are already really good at it. I know for people like Jack, he's a beast. So it's like you've got these people who are insanely good and you guys are going to get really good because remember, you guys now know like more than 99%, like 99.9% of all other people in the world about this cool technology called blockchain and this cool language called Solidity and this cool chain called Ethereum. So you're probably going to need to build stuff. What we're doing is I've actually convinced like our team to offer entirely free developer accounts with 100 million compute units a month, which is 4x what we used to have. So for any college student on campus at USC, especially at USC because Enzo goes to USC, we actually want to enable complete free access to any developer account. So what you can do is if you scan that QR code right there, you'll get access to a unique referral link that will actually key you in as a USC student, and we can give you completely free access to developer accounts. And let's say a few of you ambitious, college students, people like me, let's say you want to go actually build your own venture-backed crypto startup and like you want to make it a business and do all this really cool stuff, you might need what's called the growth tier plan, which is basically a plan we talked about. We just had 100 million compute units for the free plan. The growth plan has 1.5x that. So you might need to use a much more robust plan with more, sort of compute, and you're going to need to pay $50 a month normally for it. But what we've done is we've enabled 2 complimentary months of growth access for free. So 2 months for free growth access. And if you need it, go ahead and email that guy right there at the bottom, Jason Shaw. He's our PM and he's able to give, more than happy to give you guys completely free access to growth tier accounts when you need them for 2 months. But hopefully that was like the cat out of the bag. Hopefully you guys really are able to use this. And then to answer your question about like Alchemy as a company, we do hire for like engineering. Right now, we're not like hiring explicitly, but like we have some, if you want to reach out to us cold and like talk to some of us, or you want to get on a coffee chat, please reach out to me, Jason, anybody. We'd be more than happy. Like we might hire like some interns, but right now we're sort of in like this very like sort of high growth stage. But also like we've previously in the past, and we probably will in the future be hiring more like non-technical roles as well. So like not just like hardcore engineers, but also like go-to-market interns, like growth people, business development. So like, if you guys are interested in that at all, please feel free to reach out to me. I'm more than happy to put you in touch with the right people. And also, if you want to talk to me as well about my experience, but yeah, like the whole point here is Alchemy really, unlike other infrastructure companies that exist in the market, we truly believe, name another infrastructure company that's doing this. Like we truly believe in the university students because we know that you guys are going to be the next CEOs of the hottest crypto companies in the market. Like if you look at Jack, like that guy's already building his own company. Already super sick people here at USC, and we know we want to really make it as easy as possible for you guys to be able to develop. So that's why we're doing this.
Thank you, Nedish. Thank you.
Thank you.
Yeah,
Thank
that was
you.
tremendous.
Yeah.
Have a good night.
Absolutely, yeah, for sure. Any other questions, or is that pretty much it? Any other questions, or?
Yeah, this might be a silly question, but what does a node look like?
That's a great question. It's look, I just want to be clear. No question is silly. Like I have some of the dumbest questions of all time, and I like know this stuff pretty well.